Okay, guys. So this is problem number one. So for this problem, I think I just got that. I think I got this picture from either the previous SI session or maybe the homework problem, but I forgot where I get this image from. Uh, but I just simply this question. I made out this question, so I didn't look up this question. So like this is the type of free response problem he's gonna ask you guys in the exam. Like determine the resultant moment produced by the force at point A. What's this? Moment about a point, right? Determine the magnitude and the coordinate direction angle for the question A. So I want you to determine the magnitude and the coordinate direction angle for the previous question. What are you gonna do? So we know that force at a point is gonna give us a Cartesian vector form. So I hat, j k, and k hat a Cartesian vector for a moment. And then to find the magnitude, simply just take the square of all the I hat, j hat, and k hat, and then take a square root of them, right? And then for the coordinate direction angle, we know that it's just simply alpha equal to the corresponding moment component divided by the divided by the magnitude of the moment, right? Okay, and then determine the magnitude of the moment of the resultant force about an axis extended between D and C. What's this? Moment about an axis, right? And you know the equation for that. And then D, determine the angle between F1 and F2. What's this? Cosine inverse of the vector multiplied by the vector divided by the magnitude multiplied by the magnitude, right? Okay, so very easy and simple stuff. So free response problem, he will usually like ask you everything that like one problem just basically cover everything that you learn in chapter 4, right? Okay. All right, so let me see my solution right here. Like I worked this out last night, and let's just start this problem. Okay, so start with problem number A. Problem A. Determine the resultant moment produced by the force at point A. Okay, so what we're gonna do is that we know that we wanna have a moment at A. So moment at A equal to R cross F. What's our R? What's our F? Okay, so my R is from the point where you want to generate the moment to the point where the force is at, which is from A to B, because the force is at B, right? Okay, so this is how I found them. So from A to B, and then my force. Okay, well, I know that I have two forces right here. So and plus I don't have a point out where this force is going. I don't have a point where this is going. But even if I do, but I have a two force, then my force right here is going to be my FR, which is my resultant force. Okay, so I have to find the resultant force. How to find that? Just FR is simply just equal to F1 plus F2. Okay, so FR equal to F1 plus F2. I guess, oh, my bad. I got 7I plus 22J minus AK. Right? Okay. And then so I found my FR. I had to find what my RAB is. My RAB. So let's write out the positions. For A is at the origin. Okay. And then this is a D right here. So I just added this to this problem. This is a D. Okay. A for B. So 4, 3, -2. For C, 4, 3, 0. For D, 4, 0, 0. Okay, so guys, I'm going quick with this problem because this problem is extremely easy. Like if you listen to his class, if you go to his class and you watch my SI video, like I don't have to explain this all over again to you guys. Like you guys should get it like instantly. Like from the moment where I tell you that MA equal to RAB cross FR, then I don't have to do anything. You guys can solve it on your own. But I'm gonna show you guys how to do it. But I'm gonna go quick with this one because I have about like eight problems with me today, and they are pretty tough and pretty long. So I want to get it quick because I don't want to waste you guys time. Okay, so no further more talking. I'm gonna work the problem out. So RAB, simply just RA minus RB. My bad. RB minus RA. B minus A, so it's the same thing. because it's at the origin. Okay. All right. So I found my RAB, and then I can do my moment equation. So MA equal to I hat, J hat, and K hat. Okay. And then RAB, so 4, 3, -2. FR is 7, 22, -8, equal to. I know that I'm going to do my cross product. So what's cross product? So if I want to do I simply just cross the row where I is and cross the column where I is. Do 3 multiplied by -8 minus -2 multiplied by 22. Okay. All right. So it'd be 3 multiplied by -8 minus -2 multiplied by 22. I had, and then for J, this is J. So for J, its coefficient is always a negative, so it's not positive. But just for J, okay, for J, I know that is 4 multiplied by -8 minus -2 multiplied by 7 plus, okay, 4 multiplied by 22 minus 3 multiplied by 7. Okay, yeah. So what I'm gonna do is I'm gonna solve what I is, what J is, and what K is. And my final answer, I got 20I plus 18J plus 67K. Okay, and this is the answer for problem number 1. Okay. Oh, my bad. I'm gonna scale this down so I can do part B right here. I'm gonna use a different color for part B. So this is part B. Okay, so part B says determine the magnitude and the coordinate direction angle for the question A. So like I said, to find the magnitude of the moment, we know that angular moment simply just 20 squared plus 18 squared plus 67 squared. If I put in the calculator, I'm gonna get, let me see, I go 20 squared plus 18 squared plus 67 squared. Okay, I got 72.2, and the unit is a pound feet. Okay, so this is the magnitude. And then for the coordinate direction angle, it says the coordinate direction angle. Okay, so I know for my coordinate direction angle is alpha, beta, gamma, cosine inverse of the, I know alpha is corresponding to x, and x is right here. This is x, this is y, this is z, okay? And this is the m resultant MR. I'm just going to calculate MRA. Okay, so that's a mx or m resultant. Let's just call it MR, M resultant. So this is MY, MR, MZ, MR. Yeah, so this one is simply just 20 divided by 72.2. This one is 18 divided by 72.2. 67 divided by 72.2. All right, so you divide them and then put it in the cosine inverse. So I got my alpha equal to 73.9, beta equal to 75.56, and gamma equal to 21.88. Okay, so this is the answer for this one. All right, okay, so I'm gonna go to the next page to do part C and part D. So for part C says determine the magnitude of the moment of the resultant force upon an axis extended between D and C. Okay, so I'm gonna do my DC with the page equal to unit vector of DC multiplied by I have to find out what my R and what my F is. So between D and C, but we know that R has to go from what's that? We found our unit vector and is a DC, and then the question asks to extend it between B and C. So we have to find out our R. So our R can either be from C to B or D to B. So it's from any point on this axis to the point where the force is generated. Okay. So so I'm gonna do from D to B. So from here to here, but you can also do from C to B. R dB cross FR. Okay, so let's find out what my UDC is. So my UDC, I know that it's going to be my RDC vector divided by magnitude of RDC. That's going to be equal to my RDC is C minus D, so 4 minus 4, 0, 3 minus 0, 3, okay, so it's going to be 0I plus 3J plus 0K. And then the magnitude of this will be we simply just do, okay? Magnitude, DC, magnitude of the RDC, I got 3 right here, okay, so it's 3, okay. And then my UDC, so 0 divided by 3, 0, 3 divided by 3, 1, 0 divided by 3, 0, so it's simply just gonna be 1J, all right? And then find my RDB, so from B divided by D, 4, my bad, not divide, B minus D. 4 minus 4, 0, 3 minus 0, 3, negative 2 minus 0, negative 2. It's going to be 0, 3, negative 2. Okay? And I have all the information I needed and my FR from the previous one. That's equal to, let me see what my FR is. 7I22J negative 8K. Okay. Okay, so MDC equal to IJK. For this one, I have to put my UDC on the top. My UDC is simply just 0I1J 0K. Then the next row, I'm gonna put my RDB, so 0, 3, negative 2. In my last row, I got 7, 22, 8. Okay, and I'm not gonna do the calculation for I or K because their coefficient in front of them is 0. So which means that even though you calculate what R cross F is, you're going to be multiplied by 0. So it's going to be 0. Okay, so I'm just gonna do it for J. Okay, so I know for J, I'm gonna cross out the row. Cross out the row where J is, cross out the column. I'm gonna get 1. This is the coefficient. Okay. I'm not gonna multiply. I'm not gonna do the cross product for that one because this is just coefficient in front of it that I have to multiply it at the end. Then 0 multiplied by 8 minus negative 2 multiplied by 7. Okay. Then this is J. So on my MDC, I got 14 pound C. Okay. All right. This is our answer for part C, moment about axis. Okay. So let's move on to part D. Part D says determine the angle between F1 and F2. Okay. So F1 is right here, F2 is right here. So we have to find the angle right there. Okay. So what we're gonna do is use our cosine inverse. Alpha equal to cosine inverse of F1 vector, which is in Cartesian vector form, multiplied by F2 vector, Cartesian vector form, divided by F1 magnitude, multiplied by F2 magnitude. Okay, let's find out what the F1 magnitude is. So F1 magnitude, F2 magnitude. Let me see. Well, F1 It's a 4 square plus 12 square plus 3 negative 3 square 160. I got one. Okay, 13 for this, and then for F2, 3 square plus 10 square plus 5 square square root of 134. Okay, F1 multiplied by F2. So I'm gonna write out what F1 is. F1 is 4i plus 12j minus 3k. F2 is 3i plus 10j minus 5k. Okay, F1 dot F2 basically just means that F1x multiplied by F2x plus F1y multiplied by F2y plus F1z multiplied by F2z. And so what that is 4 multiplied by 3 I plus 12 multiplied by 10 j plus negative 3 multiplied by negative 5 k all over 13 multiplied by square root of 134. And if you input all this in calculator, you're gonna get alpha. Not alpha. Theta equals to 12.35. Okay, and this is the final answer for part D. Okay, like I said, he's probably gonna give you something like that on the exam. So actually, like I got all these questions from the previous semester's question. Like previous semester, he's gonna ask this kind of question. So I want you guys to know how to do this. Okay, because for free response, I think it was like how much 45 point, like all of 100. So make sure you guys know how to do this. Okay. Like I'm doing my best to help you guys. So like let me know how it goes. Okay. All right. So I'm gonna move on to the problem number two. Problem number two, same as problem number one. It's another practice of this free response problem.